Hello there, Mr. Sutton here, bringing you this Algebra 2 1-2 homework solutions on writing transformations of linear and absolute value functions. For all of these problems, except for maybe the last one, we're supposed to write a function whose graph represents these indicated transformations of this f function. So in this case, f of x is 2x plus 1, and we want to translate this thing 2 units to the left. So on all of these, I'm going to start by rewriting the original function with a little bit of a rule applied to it. So I'm going to create a g of x function, and the way g of x relates to f of x, since I'm going 2 units left, that means I'm going to have to add 2 inside the f of x function. So I'm going to start by writing g of x equals f of x plus 2. And now I'm simply just going to plug x plus 2 into this f function to apply this. So I can rewrite this as 2 parentheses x plus 2 plus 1. And then I just simplify this. That's going to be 2x plus 4 plus the 1, which simplifies to 2x plus 5. For this next one, I have this f of x function that I want to translate 6 units up. That means when I write g of x for this, I'm going to need to do f of x plus 6. It's an outside change, so it happens outside the function, and it's in the direction that we expect. So now that I've written this, I'm just going to replace f of x with what it represents, this 2 absolute value of x minus 9. And then just simplifying that, negative 9 and 6 combines to give me negative 3. So I've got 2 absolute value of x minus 3, and that's my new g of x function. For this one, I want to take this f function and reflect it in the x-axis. So if I'm doing the x-axis, that's a vertical up-down change. So reflections require me to negate things. Since it's a vertical change, I have to negate the outside. I have to negate the whole f function to make this happen. So I'm going to write g of x equals negative f of x. And then I simply have to replace f of x with this rule here, negative 5x plus 2. And then I'm just going to simplify by distributing this negative that I put out there. So this will be a positive 5x and a minus 2 for my g rule. For this next one, I'm trying to reflect this function in the y-axis. The y-axis is going to cause me to do a left-right reflection, a horizontal change. So I'm going to need to do something inside the input of the f function. Again, reflections are negations of values, so I'm going to have to do f of negative x. That's what that's going to look like when I write my g function. So now I'm just going to apply negative x inside this f rule. So I've got absolute value of 2 times negative x minus 1, all of that plus 3. And then I can simplify that just a little further to be negative 2x minus 1. And you could actually just stop here and call this done. This is perfectly fine. But some people like to simplify a little bit further. So you can do that by factoring a negative out of these things and calling this negative parentheses 2x plus 1. And then because this is inside absolute value, this negative can actually just go away. And this is equivalent to just having positive 2x plus 1, all of that plus 3. On this one, we're trying to perform a horizontal shrink of the f function by a factor of 1/2. Since it's horizontal, that has to happen to the input of the f function. So I need to replace the x in here with something else. And since it's internal, that means it's going to be the inverse of what it looks like. So instead of multiplying by 1/2, I multiply by the reciprocal of 1/2, which is 2. So I'm going to have to do g of x equaling f of 2x. And at this point, I'm just going to replace the x in the f function with a 2x. So this is going to be absolute value of 2 times 2x, all that plus 4, which just simplifies to absolute value 4x plus 4. On this one, I am taking the f function and performing a vertical shrink by a factor of 1/2. Since it's vertical, this is happening outside the function, and it's going to be exactly what it looks like. So I'm going to have to multiply the f function by 1/2 to get my g function. So let me just replace this f of x with the 2x plus 6. And at this point I can distribute to simplify a little bit. So half of 2x is x, and then half of 6 gives me a positive 3. For this problem, I have two transformations going on. A vertical stretch by a factor of 2, followed by a translation of 1 unit up. So to get my vertical stretch, this is an outside change. So it's going to be outside the f function, and it's exactly what it looks like, multiplying by 2. So I'm going to write g of x equals 2 times f of x. That's my first step here. And then f of x is really just x, so g of x is just going to be 2 times x. Okay, now to get this other transformation, I'm going to create another new rule using this g function that I just wrote. Since it's also a vertical change, it happens outside the g function. So, and it's exactly what it looks like. A translation of 1 unit up means I need to add 1 outside the function. So I'm going to write h of x rather, I'm going to make a new function. H of x equals g of x plus 1. But now g of x is really just this 2x here, so I can just write 2x plus 1. And that is my final transformed function. On this one, I'm trying to take the f function, which is just the absolute value, and reflect it in the y-axis, and then follow that up with a translation of 3 units right. So I'll do these one at a time, each using a different rule. I'm going to write a g rule to cause this reflection in the y-axis. Since it's the y-axis, that's a left-right sort of change, so it's going to happen to the input of the function. I'm going to have to negate the x that's being plugged in here. So I'll write g of x equals f of negative x. And just applying this f rule, which is just absolute value of whatever you're plugging in, this is just the absolute value of negative x. Now I could simplify this a little bit further if I wanted to. Since it's the absolute value, negative x and x inside there are going to give me the same thing, so I could just rewrite this by losing that negative and calling this absolute value of x, which is going to make my next step a little simpler. For the next step now, I need to translate this g function 3 units right. Since it's a left-right change, it again is going to happen to the input of the function, and it's opposite of what it appears to be. So I have to do x minus 3 to get 3 units right. So I'm going to write h of x equals g of x minus 3. And then since the g function is just absolute value, this is just going to be absolute value of x minus 3. For this problem, which is the first of the 2 honors problems on this problem set, we're taking the f function and stretching it vertically by a factor of 3. Since it's happening vertically, that's outside the function, and it's exactly what it looks like. So we're multiplying the f function by 3 then. So let me write g of x equals 3 times f of x. And then I'll just replace f of x with the rule here. So 3 times all this stuff. And I can simplify this a little bit. This is just going to be 3 absolute value of x plus 1 minus 3. For this problem, we have a big word problem here. The cost of a car ride from a ride-sharing company during regular hours is modeled by this f of x function, 2.3 times x, and that's the number of miles driven. So the more miles you drive, the more it costs. The cost of a ride during high demand hours, including a tip, is going to be 5 more than 120% the cost during regular hours. So we have this little bump up here because of the high demand, and this tip is going to give us another 5. So based on that, we want the cost of a 6-mile ride during the high demand hours. All right, so we're just going to transform this f function a little bit and then plug 6 into our new function. So I'm going to call my high demand function g. And how does g relate to f? Well, since we have 120% the cost, that's going to be 1.2 times the f function. And then we have $5 more than that, so we have to add in $5 after that multiplication for the tip. And just applying this rule to f of x, this is really 1.2 times 2.3 x plus 5. And we could simplify that a little bit. Let me just do 1.2 times 2.3 on Desmos here. So 1.2 times 2.3, that's giving us 2.76. Great. So that's our new function. Now we just have to plug 6 into this thing. So plugging 6 into that, we have, let me just delete this. We have 2.76 times 6 plus 5, and that's coming out to $21.56.